Venus is one of the most intriguing planets in our solar system. It has been the subject of scientific research and exploration for many years, with spacecraft missions such as Mariner 2, Magellan, Venus Express, and Akatsuki providing us with valuable insights into the planet's atmosphere, surface, and potential for life. Hello everyone and welcome to our channel. In today's video, we will delve into the first images of Venus and what we have discovered, the history of Venus exploration, the latest scientific discoveries, and the ongoing debate about the possibility of microbial life in the planet's clouds. We will also discuss the broader significance of studying Venus for planetary science and what it can teach us about the formation and evolution of planets throughout the universe. Join us on this exciting journey of discovery and exploration. However, before we continue, take a moment to like this video and subscribe to my channel. Without much ado, let's dive in. 1. Mariner 2 mission. The first glimpse of Venus. The Mariner 2 mission was launched on August 27, 1962, by NASA with the primary goal of studying Venus. It was the first successful interplanetary mission to another planet and provided the first close-up images of Venus. The spacecraft was equipped with a suite of scientific instruments, including a radiometer, magnetometer, and plasma probe, to study the planet's atmosphere, magnetic field, and solar wind interactions. The imaging system on board Mariner 2 consisted of a single television camera that could capture images of the planet and transmit them back to Earth. The camera used a scanning mechanism to capture images line by line, which were then transmitted as analog signals back to Earth. The camera had a resolution of about 200 kilometers per pixel, meaning that features larger than 200 kilometers in size could be resolved. During its flyby of Venus on December 14, 1962, Mariner 2 came within 34,773 kilometers of the planet's surface and took a series of 42 images. The images revealed a hot, barren, and craterless world with a thick cloud cover that obscured the surface features. However, the images provided the first direct observations of Venus and were a significant milestone in the exploration of our solar system. The Mariner 2 mission was a technological breakthrough in the field of planetary exploration and paved the way for subsequent missions to Venus and other planets. The imaging technology used in Mariner 2 has since been improved and has allowed us to obtain much higher resolution images of Venus and other planets. Today, we continue to study Venus using more advanced imaging systems and scientific instruments to better understand its atmosphere, geology, and potential for life. 2. Venus's atmosphere. The runaway greenhouse effect. Venus's thick, toxic atmosphere is one of the most inhospitable environments in the solar system. Its atmosphere is mostly composed of carbon dioxide, CO2, with trace amounts of other gases, such as nitrogen and sulfur dioxide. The high concentration of CO2 in Venus's atmosphere contributes to a phenomenon known as the runaway greenhouse effect, which leads to extreme surface temperatures on the planet. The greenhouse effect is a natural process by which certain gases in an atmosphere, such as CO2, trap heat and prevent it from escaping into space. On Venus, the concentration of CO2 is so high that it traps almost all of the heat from the sun, causing the surface temperature to reach a scorching 470 degrees Celsius, 878 degrees Fahrenheit, which is hotter than the surface temperature on Mercury, the planet closest to the sun. Scientists have studied the composition and chemistry of Venus's atmosphere using a range of techniques, including spacecraft missions and Earth-based telescopes. One of the most significant missions was the European Space Agency's Venus Express, which orbited Venus between 2006 and 2014. The spacecraft carried a suite of scientific instruments, including spectrometers and imagers, that allowed scientists to study the composition, structure, and dynamics of Venus's atmosphere in unprecedented detail. Through the study of Venus's atmosphere, scientists have made important discoveries about the planet's geology and history. For example, the composition of the clouds in Venus's atmosphere has been used to infer the presence of volcanic activity on the planet. Additionally, the high concentrations of sulfur compounds in the atmosphere suggest that Venus may have had significant volcanic activity in the past. Understanding the composition and chemistry of Venus's atmosphere is important not only for understanding the planet itself, but also for understanding the processes that govern the evolution of planets and the potential habitability of exoplanets. 3. Venus's surface. Volcanoes. Mountains and plains. Venus's surface is dominated by vast plains, rugged mountains, and extensive volcanic features. These features have been studied in detail by spacecraft missions, such as the Magellan mission, which was launched in 1989 and orbited Venus between 1990 and 1994. The mission provided high-resolution radar images of Venus's surface, allowing scientists to map and study the planet's geology and topography. One of the most striking features of Venus's surface is a large number of impact craters. These craters, which are caused by the impact of meteoroids and asteroids, suggest that Venus's surface is very old and has not been geologically active for billions of years. However, the discovery of volcanic features on Venus's surface contradicts this idea. Venus has one of the most extensive volcanic provinces in the solar system, called the Volcanic Rise. This area is characterized by large shield volcanoes, such as Matmons, which is one of the largest shield volcanoes in the solar system. The volcanic rise also contains a variety of other features, such as lava channels, rifts, and volcanic domes. Another notable feature of Venus's surface is the tessera, which are highly deformed and fractured terrain that form complex patterns on the planet's surface. The origin of these features is still not fully understood, but they are believed to be related to tectonic activity and deformation. The high-resolution images from the Magellan mission also revealed numerous mountain belts on Venus's surface, including the Maxwell Montes, which is the highest mountain on Venus. These mountains are believed to have formed through tectonic activity, and they provide evidence of the planet's internal geological activity in the past. 4. Venus Express and Akatsuki missions. Advances in Venus exploration. In recent years, there have been several missions sent to Venus, including the European Space Agency's Venus Express and the Japan Aerospace Exploration Agency's Akatsuki mission. These missions have provided new insights into Venus's atmosphere, geology, and climate, as well as the potential habitability of the planet. The Venus Express mission, which orbited Venus between 2006 and 2014, was designed to study the planet's atmosphere and its interaction with the solar wind. The spacecraft carried a suite of scientific instruments, including a spectrometer, a magnetometer, and an ultraviolet and infrared camera, which allowed scientists to study the composition, structure, and dynamics of Venus's atmosphere in detail. Some of the key findings from the Venus Express mission include the detection of water vapor in the planet's atmosphere, which may have implications for the potential habitability of Venus, and the discovery of a huge double-ion vortex in the planet's south pole. The Akatsuki mission, which was launched in 2010 and entered Venus's orbit in 2015 after a failed attempt in 2010, was designed to study the planet's atmosphere and surface using a suite of instruments, including a camera and a spectrometer. One of the main objectives of the mission was to study the mysterious superrotation of Venus's atmosphere, which causes the atmosphere to rotate much faster than the planet itself. The Akatsuki mission also provided new insights into the geology of Venus's surface, including the discovery of a possible active volcano on the planet. Together, these missions have significantly advanced our understanding of Venus and provided important insights into the planet's atmosphere, geology, and climate. They have also raised new questions about the potential habitability of Venus and the processes that govern the evolution of rocky planets. Future missions, such as NASA's proposed VERITAS mission, which is set to launch in the late 2020s, will continue to build on the discoveries made by these missions and further advance our understanding of this fascinating planet. 5. The possibility of life on Venus. A fascinating debate. The possibility of life on Venus has been a topic of intense debate among scientists and the public for many years. While Venus's surface is a harsh and inhospitable environment, with temperatures that can reach up to 460 degrees Celsius, 860 degrees Fahrenheit, and pressures more than 90 times that of Earth's atmosphere, some scientists have suggested that the planet's clouds could be a potential habitat for microbial life. In September 2020, a team of scientists announced that they had detected the presence of phosphine gas in the clouds of Venus using data from ground-based telescopes and the Atacama Large Millimeter Array in Chile. Phosphine is a gas that is typically associated with microbial life, and its detection in the clouds of Venus has led to speculation that there could be living organisms in the planet's atmosphere. However, the detection of phosphine on Venus is still a matter of debate, and other scientists have suggested that the gas could have non-biological origins. For example, the phosphine could have been produced by chemical processes in the atmosphere, or it could have been brought to the planet by meteorites or other sources. Despite the ongoing debate, the idea of life on Venus has captured the public imagination and sparked renewed interest in the planet. Some scientists have proposed new missions to Venus to study the planet's clouds and search for signs of life, while others have suggested that future missions to the planet should be designed to avoid contaminating any potential life forms that may exist. 6. The significance of Venus research. Lessons for planetary science. Studying Venus is significant not only for understanding the planet itself, but also for gaining insights into the broader processes that govern the formation and evolution of planets throughout the universe. By studying Venus, scientists have been able to gain new insights into the mechanisms that drive planetary evolution and how planets interact with their environments over time. For example, studying Venus's atmosphere has provided important insights into the greenhouse effect and its role in shaping planetary climates. Venus's thick, toxic atmosphere and extreme surface temperatures are a result of a runaway greenhouse effect, in which the planet's atmosphere traps heat and causes temperatures to rise to extreme levels. Understanding the mechanisms behind this effect can help scientists better understand the potential for habitability on other planets, as well as the long-term effects of climate change on Earth. Similarly, studying Venus's geology has provided new insights into how planets form and evolve. Venus's surface features, such as its volcanic plains, mountains, and impact craters, provide important clues about the planet's geological history and the processes that have shaped its surface over time. By studying these features, scientists can gain new insights into how planets evolve and interact with their environments. Moreover, Venus's similarities to Earth have also made it an important target for planetary science research. By studying Venus, scientists can gain new insights into how planets with similar characteristics evolve and how they interact with their environments. This can help scientists better understand the origins and evolution of our planet, as well as the potential for life on other planets. In conclusion, Venus is a fascinating planet that has captured the attention of scientists and the public alike for many years. From the first glimpse of the planet by the Mariner 2 mission to the more recent spacecraft missions, such as Venus Express and Akatsuki, scientists have made significant advances in our understanding of Venus's atmosphere, surface, and potential for life. Thank you for watching. I hope you enjoyed learning about Venus and the fascinating discoveries that scientists have made through spacecraft missions and research. If you want to learn more about space exploration and planetary science, make sure to subscribe to our channel for more exciting content. And as always, feel free to leave your comments and questions below.